my name is John Gilnissi, and welcome to today's webinar featuring the award-winning MeshWorks engineering software platform. We have a great agenda today, including segments to address warpage correction and part distortion in injection molded designs. We'll provide software demonstrations and an overview of best practices using innovative tools for the automation of simulation processes. We look forward to presenting to you and also receiving your comments and feedback when we reach the Q&A session. At any time during the webinar, feel free to type in your questions in the text box area, and we'll answer as many questions as we can at the end of the presentation. Detroit Engineered Products, or DEP for short, is your host today and also the creators of the MeshWorks software platform. We are a 22-year-old company that has grown to about 500 engineers with technical centers in 6 countries, vendor partners in 15 countries, and our global headquarters in the Metro Detroit area here in Michigan. DEP is comprised of 4 groups, including our engineering and analysis group, our product development team, which helps OEMs, suppliers, and investors bring specialty components and innovative products to market, our MeshWorks software division, and our staffing and contracting team. So without further delay, we hand the baton over to Raj.
Thank you, John. Thanks for the introduction to DEP. Thank you, everybody, for joining the session. DEP has its own proprietary software, MeshWorks, as you all know, and we would like to first give a small introduction to our software. Okay. MeshWorks is a CAD parameterization tool. It ideally helps the FE and CFD models to get converted into parametric designs, thereby enabling faster design iterations and quicker DOE studies. With DEP's morphing technology, we can easily achieve design solution upfront with the help of morphing on CAD and CAE models and also CFD without any kind of initial concept. So you can start right away with the legacy model and start the process. Next is our design optimization capability. MeshWorks enables the MDO process with the help of its parameterization and morphing approach. Using MeshWorks, you can parameterize one domain. Take, for example, I create all my parameters and morphing in the crash model. Now, without repeating the same process again in NVH and durability, I have a transformation approach within MeshWorks, which will enable you to transform all these parameters into other domain models also with just a click of a button. Next is our process automation capabilities. As we all know, MeshWorks is widely used across many OEMs and tier 1s. Nowadays, we started receiving a lot of customized requirements from the customer. And we developed automation for the day-to-day workflow at the customer locations, and we will provide it to them free of cost. The advantage of the process automation is an engineer currently spending 8 hours on the task with DEP's process automation would only spend 1 hour of his time. So we talk about 70 to 80% of time saving with MeshWorks process automation approaches. And next is our pre and post processing capabilities. As we all know, MeshWorks is a parametric modeling and morphing tool. On top of that, it has the pre and post processing capabilities. In fact, there are a lot of built-in scripts, which is helping the meshing time reduction, automated assembly tools, and a lot of scripts which can extract the results for the complete DOE designs without any user interface. Finally, we launched our new tool called ConceptWorks recently. ConceptWorks is a tool which will help an engineer to perform quick architectural changes and perform a lot of conceptual studies. which ideally will be a process where the CAE engineer needs to talk to a CAD guy and get some development at the CAD. Then he brings it to the CAE model. Then he builds it by himself. But now, thanks to ConceptWorks, the entire process is automated. You can very well go and pick your load paths or architectural design changes. With a click of a button, you can generate the members, which are in fact parametric. With all these features on MeshWorks 2020, we would like to share our presence on the product development cycle. Here is the comparison of the current trend versus new trend using MeshWorks on a typical product development cycle. In general, people spend a lot of time and efforts on the detailed and visual validation phases. But with MeshWorks, you can do all the heavy loading in the conceptual stage itself, wherein you don't need any CAD to start. You can straight away take the FE models from the legacy designs that are available in our database, and then you can build your concepts and perform all the parameterization plus the DOE studies in the conceptual stage itself. So by the time you cross a concept, your design will be like 90–95% frozen. So our efforts on the last stage of virtual validation maintenance will be much lesser as compared to the current trend. And these are the modules which will be handy to you when you work at different stages. Our morphing and concept modules and our ConceptWorks tools will be the key enablers in the conceptual stage. Parameterization and optimization modules will help in the detail, and throughout the product development cycle, you can have MeshWorks actively participating to reduce the overall time frame. Saying all this introduction to our software, we would like to move to the topic of warpage effects on the plastic designs. Here is the pictures which gives a comparison of what is our nominal design, and when the part gets manufactured post all the cooling with the shrinkage and warping effect, you can see like there are deviations with respect to what we actually expected. You can see the clips can deviate, locators, dog houses, and even the base structure too. But these are all attachment locations. They play a very important role in the assembly process. They need to stick much closer to the nominal shape. Now let's look into the challenges which we currently face when we incur with all these warpage issues. First one, the deficiency on the part distortion, which is going to add a lot of additional force into the assembly process. This force assembly process will in turn add a lot of pre-stress to the glues, which attaches these trims to a metal or any conditions. With all these pre-stresses, we will end up with a lot of performance deteriorations over the period of time. In fact, the bolt connections, locators, dog houses, or clip location, they all get overloaded when they get clamped, which is not the real load case which we design in our DEPR. So these are all like additional loads which will come into the structure, and it will deteriorate the performance. On top of all these effects, there is no good method which is available currently to study the debonding effect from the assembly process. Now let's look into the plastic part distortion minimization, which is going to be powered by MeshWorks process. Here is a typical flow chart comparing with a conventional process and the MeshWorks process. In a conventional process, if there is part deviation identified, it has to start with a CAD design, followed by a mold flow analysis, wherein we identify the shrinkage and warpages. Then we update the design, prepare the mold. We still end up with warping, which is not corrected with more accuracy. And in fact, there is no direct process to do that. However, with MeshWorks, we can take the prototype, scan the part, generate a CAD from the STL scan data. We can overlay the nominal CAD and the scan CAD. Will identify the delta difference. To identify the delta difference, MeshWorks internally has a process which will identify the difference, and it will do a reverse compensation with a vintage process within MeshWorks. So you will have a warpage compensated CAD design directly generated from MeshWorks, which we can take it forward for the die phase studies, and further prototype generation. And with number of benchmark studies and projects which we executed with our customers, we are proud to say that our approach was having a very minimal warpage as compared to other processes that currently exist as we speak. Now, let's look into this case. So the first step is to scan the actual design, generate the point cloud data. From there, we'll be generating the CAD design, and you can see the overlay of the nominal CAD and the scan CAD. So if you look at it, you can clearly see there is a difference which is existing resulting from the warpage. Now let's see in the next slide the overlay pictures. You can see like the warping is in such a way the upper region moves in a specific direction inward, and the lower region moves outward. So here is nominal versus scan CAD comparison. So this manufactured part is having the differences resulting from the part warpage. As we discussed, this is going to undergo pre-stress condition. In fact, it will not have a proper fit with the matting, which is not a desirable condition. And the scenario calls for a better alignment without any deviation from the nominal CAD. Now we will explain our process. So we have a parent mesh modification technology which will perform the reverse vintage process. Section 1 and 2 clearly shows how the reverse vintage is happening on two different regions. In fact, the representative sketch on the right extreme will show us like the blue color scan CAD. When the warpage compensation is appended to this model, it goes into the reverse direction of where it stands with respect to the nominal CAD. To achieve this change, we have a parent mesh modification tool which needs your nominal mesh and the deform mesh. The deform mesh can come from Moldflow, or you can just bring in the scan data and you can use this STL2 to morph the nominal CAD to get it compensated for warpage. So now, in the next slide, we will show how the prototype when we did all the warpage compensation looks like. The yellow color, the red is the nominal one. When we manufactured the prototype, blue color was the skin, which was actually staying away from the actual required location. This is an effect of warpage. MeshWorks compensated warpage and did a reverse windage on the scan mesh. That's the yellow line. And MeshWorks generated the CAD for this part, which was further used for die phase correction. And then the part, when it was manufactured, you can see, which is in the gray color, which is much closer to the nominal CAD. So this will give you a clear idea like how our process is. Now I would let Paresh to take it forward with a live demo on the process. Paresh, thank you.
Thank you so much, Raj, for the introduction. So as Raj has explained nicely that how quickly we can do a reverse vintage or a warpage correction in MeshWorks. So we will see that. So here we see a plastic injection model on the screen. Now we have few models. So I will quickly go ahead and show the nominal mesh. So this is our nominal CAD, which is a 3D part. And we also have a nominal mesh, which is exactly sitting at the midplane of this CAD, as we can see on the screen. Now, as Raj explained that when we have a CAD data, scan data, from the scan data, we also have the warp mesh. So this is our new warp mesh. So as we can see, there is a clear difference between the initial CAD and the scan data CAD. Now in MeshWorks, we have a nice tool where we can do this reverse vintage or warpage correction in MeshWorks. To do so, we need to go in Tools, Parent Mesh Modification. So here here we need to select two files. First is the source midplane mesh, where I need to go and select my baseline model. That is nothing but the nominal mesh. So this is the nominal mesh which we just saw on the screen. Now I will bring the warp mesh, as we can see on the screen. So you can clearly see the deviation between the nominal mesh and the warp mesh. So now here we have an option where I can select the nodes. Either a user can select the nodes of a section, or he can select the entire component to modify. Then we have two options. One is either we can go with a percentage basis, or we can go by the distance. Let's go ahead and see the percentage change. I'll quickly go here and zoom in to show you the difference. So MeshWorks very nicely calculates the percentage change between the first point and the second point, which is close to it, and it will work very nicely with respect to that. Let's say I give 110% and simply click on execute. So as we can see that the blue mesh is modified and it is moving away from the scan data. I can also go with a higher value, let's say 130%, as you can see. Similarly, we can go in the negative direction too. That is, I will go with an 80, which will bring my mesh very close to the red component. We can also go with the distance. I will just give, let's say, distance as 4 and simply click on execute. Or I can go with the minus direction, likewise. So this is how, this is how we can correct the warpage, and that would be our final output. Once you are satisfied with the final output, simply go ahead and export the file out. And now the second step. Now I will show you how quickly in MeshWorks we can create a CAD for a warpage corrected mesh. I will go in a CAD Morpher. So this is the same CAD which I brought in our new module that is called as a CAD Morpher. So as we can see, this is the same 3D part. Now, just to show you, we have the same nominal mesh, which is exactly sitting at the center, as we can see here, or on the mid plane. And now I will show you the warp mesh. This would be the warpage corrected mesh, which we can export it from the previous window. I can zoom, I can just rotate the model just to show the complete model. So if we have the nominal mesh, nominal CAD, and the warpage corrected mesh or the warpage compensated mesh, then we can go in CAD Morphing. We have a nice tool that is called as an imposed deformation, where I need to select the CAD. So by display, I'm selecting the CAD, and then I need to select the undeformed FE file. This is my baseline, and this is my warped model. And simply click on Impose. So what MeshWorks will do here is, MeshWorks will very nicely identify the delta change between the undeformed mesh, that is the nominal mesh, and the warpage compensated mesh. And it will impose that delta change onto the CAD so that we will get a new warpage compensated CAD. So this is how quickly and efficiently we can get a new warpage compensated CAD in MeshWorks. Just give a minute or so. Let's assume you have a large component and then you follow this step, and that's how you can quickly go ahead and create a new CAD, and you can do the die phase study. So this is how a new CAD has been generated. I will quickly go ahead and show you the old CAD. And also I will show you now the nominal and this would be my nominal mesh, and this would be my warp mesh, which is still again sitting at the center after the CAD has been updated. So this is how quickly and efficiently we can do an imposed deformation in MeshWorks. So usually for this warpage compensation, it takes around 32 hours, but in CAD Morpher, it's just about 2 hours for a complete model. Raj? You can go ahead, Raj.
Thanks, Paresh. So now, coming into the advantages with respect to DEP's process, we can achieve a better design, which will be a close representation of our nominal CAD, which we intended to get reflected as a part. Using MeshWorks, you can very well handle the pre-stress conditions. We can, in fact, eliminate almost all the pre-stress conditions that could result as a result of forced assembly process. The CAD model generated, will have a much closer tolerances and reduced warpage. So we can say, like, ideally, very, very minimal geometrical distortion. On top of all these things, the time it takes with a conventional process and MeshWorks, it's significantly going to save a lot of time for the user. The demo which Paresh gave would only take like 10 minutes to 15 minutes to ensure like all the checks and balances are made in the design. So we can do a lot of iterations to achieve a closer design with the help of MeshWorks, and MeshWorks save a lot of time and ensure a design closer to your expected nominal CAD.